Okay, so welcome back. Today we're going to take the next step in learning how to program our test instruments. And as you can see here, we've got our oscilloscope and our function generator set up. And previously we had developed this application that was being used specifically to do a frequency response analysis. And I encourage you to look at the previous videos so you can see how to do that. And what we're going to do here is we're going to take the next step. We're going to modify this so we can, by pressing a button, we can grab the waveform that you see here on our oscilloscope coming out of the function generator. We're going to grab that waveform and plot it here in our C# or whatever software you want to use application on Visual Studio. And once we have that waveform, we can modify it, we can evaluate it, we can save it to file, we can do whatever we want. So here I've got, I've added a read waveform button. So all I have to do is press this button and automatically you can see we have updated our chart, and we show from 0 to about 24 milliseconds. We've got a square wave with a peak of about 5 volts, and that's exactly what we show here. So we're going to show you in this video how to do that. We're basically adding that to the existing application, so we'll be able to not only do frequency response, but also grabbing waveform data with the press of a button. And maybe in the future what we'll do is we'll have it automatically update to whatever is shown on the oscilloscope. So let's take a look at the code and see how we can implement this. Okay, so now let's take a look at the code we have so far. I encourage you to look at the previous videos. It'll help you get up to speed on where we are right now. And this is the application we had for the frequency response plotting. And all we're doing in this is we are adding the ability to grab a waveform from the oscilloscope, whatever's shown on the screen of the oscilloscope. Again, it's really basically the same user interface that we had before. I just moved some of these controls around, and I did add this one button to read the waveform, and that's going to, when you click on that, it's going to go out, grab whatever is the waveform is on the screen and put it in this chart. So read waveform, I changed that button name to BTN wave, and you can imagine the event handler for this, when we click this, is going to actually do the grabbing. So if you look here, everything is about the same. We've got our using statements, documents to do, initializing, I haven't changed that. Main form, haven't changed that, except for we have a configured chart for the scan, and I commented it out, and I'm moving it to a different location, and we'll see why in a bit. So, but everything else is the same. I haven't changed anything there. All this other stuff is the same. And as you can imagine, the only new event handler is going to be that BTN wave event handler. So we've got the scope, open session, close session, hasn't changed. The COM port, open and close, sweep frequency response, clicking that button. And here is the event handler for this new button to grab the waveform. Timer tick we don't use, and these are the same. So what's in BTN wave? Very simple. We now call a method to grab the waveform from the scope, right? So as you can imagine, there's going to be a new method in here to do that. Now, here are the methods. Open COM port, that doesn't change. Configure signal generator, we're not using that in this, so it doesn't change. Here is the two methods now where we can configure the chart that displays either the frequency response graph or the grabbed waveform. So what I've done is I had configured chart was the name of this method. I just changed the name to configure chart scan. So we know that this is for the frequency response. The next one that we've added for this is configure chart waveform. And we're going to be feeding it a couple values, but we'll look at it in a bit. Very similar, it just allows you to configure the chart so that you can plot whatever the received waveform is, all right? Read frequencies file, that doesn't change. Write log file, write data to CSV, those don't change. Set frequency. And the other two that we made changes to are the read scope. This previously was called read scope. I changed it to read scope scan, and that would allow us to read the frequency response results. And I added a new method, read scope waveform, which is what's going to be doing all the work here to grab the waveform. The rest of them haven't changed. Filter input volts, we don't use any of these. So as we said, when we click this button, BTN wave, it's going to read scope waveform. So let's go over and look at that. Read scope waveform, and this is what goes out and grabs the data from the scope and plots it on the chart. Now it looks like a lot. In fact, it's really not too bad. I've got a couple lists of doubles for the X values that we read from the scope and the Y values, or the time and voltage values. We're putting those in a list. We have an integer called TMC length, and we'll talk about that in a bit. It basically defines, when we grab the bytes of data that define the waveform, it has in the front of it a what's called a TMC header, which is 11 bytes that we're going to discard. So this just tells us to discard the first 11 bytes. Total waveform bytes, I put 1500. It'll depend on your scope, how many bytes you grab for a waveform. And we've got X increment double, Y increment double, and volts per division. Those are variables we're going to get from the scope to define how the scope is set. Now, in order to get the data, of course, we're going to have to send some commands. We're going to have to write some commands like we did before for the frequency scan, but we're going to write different commands and get different data. So here is a list of the commands that we're going to write in order to grab the data. Now, how do we know about these? Well, it's really important that we go back to the Rigol scope we're using, the DS1054Z, and this is the programming guide we talked about previously. So in order to understand what we're going to get from the scope when we ask for a waveform, we're going to have to know what we're going to get, what's the format. And here is the waveform section. It's got waveform commands, and it explains what the different variables are. You can see we can address the source, the mode, the format, the data, which is the actual data we're going to get for the waveform. We're going to use this. Increment, origin, reference, Y origin, start, stop, and preamble. So we're going to need some of these. And one of the important things we're going to have to be aware of is when we grab the data using this data command, this is a question, which means we want to read the data. We're going to have to understand what format the data comes in. Here's a bunch of stuff that explains, but we talked about TMC. Here it says the return format, the format of the data. It's basically a byte array of bytes. And it's going to start out with what's called a TMC header. And here it says the format of the TMC data description header is pound, N, and a bunch of numbers. And it turns out there's 11 numbers that give you this header, right? Pound is the denoter, N is 9, and the 9 data following it denote the number of bytes of the waveform data. And we're going to basically grab those first 11 bytes and discard them because we don't need them. Now, you may need them, that's up to you, but I'm just going to discard them to make it easier. And then the rest of the data that we grab using this data command will be the actual bytes defining the waveform. Here is the list of commands we're going to send to the scope using the exact same format we used before with an MB session, raw IO write, replace common escape sequences. And what we're doing is we're first saying source is channel 1. You can change that if you're going to use a different channel, but I'm using channel 1. The wave mode, we're going to use normal, which basically gives you what's on the screen of the scope. Wave format is byte. We're going to get a byte array. Start is going to be byte number 1. Stop is going to be, I put 250,000. It's not that much, but we'll see that depending on your scope, you're going to have to change those numbers. And then the actual request for the data defining the waveform is this wave data question mark, all right? So once we send these, it knows it wants to get byte array data from channel 1, and it's going to send that back with the TMC header. We've requested, now we need to read the results. I'm using a total waveform bytes of 1500. Actually, it's going to send us about 1200 bytes, but I'm using 1500 just to be safe. And this is going to read that 1500 bytes and store it in a byte array called waveform byte array. So when we do this, we should have an array of 15 or 1200 bytes that define the waveform and the TMC header. And what I'm doing is I'm taking that byte array, converting it to a list because it's a little bit easier to work on the list, especially if we have to strip off or discard the first 11 bytes. So we've got a list of the bytes defining the waveform and the header. And here what we're going to do is just go through the first 11 bytes and remove them from that list. So that's all remaining in this waveform byte list will be the actual points of data. So we go I equals 0, I less than TMC length, and we define that as 11 bytes, and just remove those values. So it's going to be down to just the values of the points. And then we can feed that back to our text box, waveform data length, and we can see what the remaining waveform byte list.count is, and that should print that out. It should be like 1200. Now what we need to do is we need to figure out, we've got all this data, but it's going to be scaled depending on how the scope is set up, right? For the volts per division on the y-axis and the same thing on the x-axis. So we're going to have to ask the scope, hey, what's your setting right now? And to do that, we're going to use, for the y-axis, we're going to use this first group of commands, and the x-axis, we're going to use the second group of commands. And again, it's in the same format as we've been doing so far. We do a write to get what we want is the y increment, and that will give us information about what those values we get, what the scale is. And then we're going to read the result. We ask it, what's the y increment? It's going to send us back the y increment, and that's going to be in a byte array. And it's going to then be taking that byte array, and to get a string from that byte array, we're going to do encoding.default.getString for that byte array, and that will give us a string which is going to be an exponential value defining the y increment. All right, so it's going to be a string that's like 9.100 e to the x. So then, as we did before, we're going to do this try parse, and we're going to use this y result to string in and try to parse that into an actual number, not a scientific exponential. And we're going to send out the y increment as a double. All right, so it'll convert that scientific notation to a double and name it y increment double. We'll do the same thing for the x increment. What's the time scale? So we write waveform x increment, and then the byte array we're going to call x increment when we read it, and then we're going to convert that to a string, all those bytes, convert it to a string called x result, and then parse that, and the output will be x increment double. So that's the actual number in a double format for the x increment. So now we've got y and x increment as actual numbers, and we're going to have to use that to figure out the scale for our chart. So now let's take a look at what would happen if we merely plotted the data we got back, this waveform byte list, the list of bytes that describe the waveform. Let's see what happens if we would just plot that directly versus this index that counts through each of the elements of the byte list. And let's see what we would get on our chart by plotting just this list of bytes. So I'm going to start up the application, open session, and now we're going to read the waveform and plot it. And you can see we have a really nice sine wave, which is what we see on the scope. However, the y voltage scale is way off. And also there is no real time scale. It's just counting through each of the 1200 elements, all right? So somehow we got to figure out how we can get a decent, correct Y and X voltage scale. So we're going to have to do a little modification to our code to figure out what the correct scales are. So what we're going to do is I'm going to comment out this and uncomment this correct code. And what we're going to do is we have come up with the scope has told us that the X increment or the time increment is going to be this X increment as a double. So this is going to the actual time scale is going to be X increment double, not just this index number. So each time through, we're going to multiply the index times this X increment double, and that will give us the correct time scale, all right? We're going to do something very similar with the voltage scale. We have to take that byte values from that waveform byte list, and we're going to have to convert them to doubles because they are bytes. So we're going to have to do that. We're also going to have to get the correct scaling. Now, in this case, all of these are offset by a value of 127. If you look in the programming guide to see that, but they're all offset by 127. So we have to subtract 127 from the resulting double, and then we need to multiply that times the correct scaling factor, which is this Y increment double, and that will give us a correct Y value to plot. So let's go through and do the same thing all over again, and I'm going to uncomment this chart configuration, and we will run it, open the session, and then read waveform. And you can see now we have a correct scaling. We have a 5 volt peak value, which is correct, starting at 0. And these are 2 milliseconds, 4 milliseconds, 24 milliseconds. So this will give us the correct actual values, okay? So now we have filled out our X values and Y values with correct numbers. We also look in the programming guide, the volts per division is equal to this Y increment double times 25. So that'll give us the volts per division. So we can feed that into volts per division and X increment double into the configured chart waveform to actually configure the chart to make it work. So let's run to the configured chart waveform and see what it does. So we're feeding the volts per division and X increment as a double, and this will set up our chart for the waveform grabbing. We're clearing the legend, and then you can just pause and copy these. Basically, I have 4 divisions plus and minus, or a total of 8 divisions. So we're setting the maximum equals the volts per division times 4, the minimum, the minus volts per division by 4. And then the major grid interval is going to be the volts per division. The line color, I set it to gray to make it not as dark. And the interval is going to be volts per division. For the x-axis, going to do similar. The x increment that we're bringing in times 100. The line color is going to be gray. The maximum is x increment times 100 times 12, because I've got 12 divisions horizontally, and it's going to start at 0. So that will set us up with the correct chart configuration. When that's all done, we've got the chart set up and we've got our X vals and the Y vals. All we have to do is bind to the X vals and Y vals to actually plot the data. And then we can do an append text to just tell us what the volts per division are, and the X increment double just to get some feedback. But that's about it for the application. We open the session, and now we have a correct waveform as we see it on the scope. Now, what we can do in the future, if anybody's interested, is we can have this automatically update rather than having to read the waveform. Every time you click this, you read the waveform. So now what I did is I went over to the function generator and changed the waveform. click on that and you can see it automatically updates every time I click. So ideally, maybe you could have this automatically update. We might look at that in the future. But that's about it for this video. If you're liking these videos, please hit the like button, subscribe, hit the bell notifications, but most of all, please let others know that we're here so we get some views. Really appreciate it. Otherwise, take care. Have a really good day. Thanks.